Hey guys, just wanted to say goodbye to the seniors. This will be the last video you need to watch for me, as next Tuesday will be the last quiz. So congratulations on almost being done. Hope you have a great day, and hopefully you stop and wave on Friday because I will be there. And if it's raining, I'll be in one of those tent chair things. So look for me in there. All right, have a good day, and let's get on with the final lesson. Congratulations, last time you have to listen to Miss Dunbar. If you guys even do, I have no idea, but I assume some of you are because you were doing quite well. Today we're doing 12.1 day 2. We're covering examples 3, 4, and 6. This is going to be a longer lesson. I apologize. Our goal is that we will be able to investigate one-sided limits using charts and graphs, along with look at unbound limits. And I feel like we did this at the beginning of the year, but it wasn't so formal. So this should also be a review. And I know we talked about this, but it wasn't a thing at the beginning of the year. But there are left-hand limits and there are right-hand limits. Maybe it should be side, but I think it's hand. So anyway, the left-hand limit looks as follows. The limit as x approaches c from the negative. So c from the left, the limit of f of x is L1. And a right-hand limit is written the limit as x approaches c from the positive. So we are coming from the positive side, meaning we are coming from the right. F of x equals L2. And so there is an existence of a limit. This is very similar, again, to what we did in, I don't remember when, October? Existence of a limit if L1 equals L2. So first of all, if they are going to the exact same place, then the limit as x approaches c from the left equals the limit as x approaches c from the right, and they both equal L. So tonight I'm just going to ask you to look at just one side of a limit sometimes. And we'll look at this. So here's our example. We want to look at the limit as x approaches 0 from the left of the absolute value of 3x over 3. And so if we are approaching it from the left, that means we're going to make our table of values and we'll go just to the left. So negative 0.001, negative 0.01, negative 0.1. And when I plug 0 in, oh, Gina, this would have a limit. Miss Dunbar. This is supposed to be over x. So, excuse that error. The equation should be the absolute value of 3x over x. And when I plug 0 in, it's undefined. When I plug in negative 0.001, I get 3. Negative 3. And when I plug in negative 0.01, I get negative 3. And when I plug in negative 0.1, I also get negative 3. And it doesn't matter what value of x I put in here, this graph just looks like negative 3. So here, we say the limit is negative 3. And let's see if we can do the right side appropriately. So x approaches 0 from the right. That'll be your turn. Give it a shot. So fill in your chart and see what you get for your limit. All right, if we had 0, 0.001, 0.01, 0.1, still 0 is undefined. When I plug in 0.001, I get 3, 3, and 3. And so as I approach from the left, it's going to 3, or right. And as I approach from the left, it's going to -3. And so -3 does not equal 3. So we say the limit as x approaches 0 of the absolute value of 3x over x does not exist. And if we were to look at it graphically, I think you would see that -2, 2, it looks like this with an open circle, and it looks like that. Oh, and there's the graph. So you can see graphically, it doesn't look like it. And so that is what we look at when we look at left-hand limits and right-hand limits. Tonight, some of your homework will just ask you to do one. Sometimes it'll ask you to find a limit. And so we'll go from there. And then the other side was unbound limits. And unbound behavior, that's when we're going to infinity and beyond. As Buzz Lightyear would say, unbound behavior is if a graph goes off to positive or negative infinity, those are considered unbound limits. Unbound limits. And so we'll do those little graphs like I did. And again, if you pulled out your book from the beginning of the year and looked at limits, this would look very similar. But I'm hoping that when you do your classwork today, your notation is much better than it was, because that was the one place you guys really struggled, was writing limit notation. So if I have a graph here, and this is C, and the graph looked like this, we would say the limit as x is approaching C. Well, from the left and the right, it's going to positive infinity. And if this is C, and here we're going down, sure enough, we would say the limit as x is approaching C is negative infinity. And then finally, if this is C, and let's say this half is going here, and this half is going there, the limit as x is approaching C does not exist. And so when you are doing these unbound behaviors and you're asked to support your answer numerically, we want you to make a table. If you will recall, I promised after next week, you won't have to make a table in the next part, but you do this week. So if you are investigating limits to positive and negative infinity, and you have to support answer numerically, then you will add, your table will go plus or minus 10, plus or minus 100, plus or minus 1,000. If you need to, you can go to plus or minus 10,000. But so here's a year term. We want to look at the limit as x approaches negative infinity of -3 over x squared plus 2. So make a table. You're going to negative infinity, so you don't need the plus, you'll just need the minus. All right, hopefully you created your table. We don't care what 0 is. We do -10, and I believe it's 1.97, -100, and let's be honest, if you get the gist here at -1,000, you don't need to do -10,000. And really the goal is that we're not going to be supporting our answers numerically very soon. And sure enough, if we are going to negative infinity, remember we're going to negative infinity, this looks like it's approaching 2. And there we go. So hopefully this looks familiar to you. Sorry for the long lecture. Hope you have a great weekend. Bye.